bride, something touched me deep inside the day the music died. So bye bye Miss American Pie, drove my Chevy to the levee, but the levee was dry, and them good old boys.
Drove my Chevy to the levee. How many songs can you find that have a levee in it? That's what this particular video is about. It's about all the different methods that we use to move water from one location to another, and what we do to protect ourselves from waters, for instance rivers, that will overflow their banks. So these are man-made devices, and they all have their own separate little environmental impacts. You can follow along beginning on page 242. Okay, let's get started. Alright, so this is all about the altering the availability of water. And let's start with some human created devices. These devices are used to hold water back. The two pictures that you see here are of levees. This first picture is a picture that's in your book of a levee that did not hold up against the pressures of the water, and as a result the levee broke and all of this river water is rushing in and flooding this field. You can see that happening here. So what's the deal with levees? Well, a good way for you to picture a levee is it's a large cement or sometimes dirt structure, and it's usually designed at the bend of a river. At a bend of a river, like here. And, you know, the best picture I can draw for you is to think about one of those Disney rides. You know, water rides, like the, what's it called, the luge or something like that. Look, you get on these rides and you notice something. You go down these canals that are filled with water, and it goes at different speeds, and then there's a rapid area. But almost always there's an area where the canal makes a big turn. And always, if you recall, when you're on that ride, when you get to the turn, the water splashes over the edge of the canal. Well, that's what happens with rivers. When rivers make a wide turn, they have a tendency to splash over, especially if the river is full of water, like it is in the springtime from those melting snows in the mountains. Now, ordinarily, that produces fertile floodplains, and you can see here in this diagram, usually where oceans have a bend in them is very fertile land, and that's because as the water comes around and it's flowing and it's moving, if it does have a tendency to jump its banks, say here, well, there's a lot of soil, there's a lot of silt in that water when it jumps its banks, and that silt accumulates over time and makes for very fertile agricultural land. So that's the way it was. As a result of that, of course, then that's where we want to be living. And so humans have decided this is where we want to congregate. So oftentimes at the bend of a river is where a town will spring up, or there'll be lots of agricultural areas and then a town to support that agricultural area. The point is, it seems to be a place where humans like to live, even though we know for a fact every year that river, especially in the springtime, is going to jump its banks and it's going to flood. So we build these levees, we hope that they'll hold up, but you can't trust that it will. For instance, in this example, probably the best example of levees not holding up, of course, was New Orleans during Katrina. So what's bad about levees? Well, for one thing, is the fertile soil going to be added to the agricultural lands anymore? If we have levees built up all along the riverbank, the answer, of course, is no. So that soil is not going to stay fertile forever unless we use really good farming practices. Some of those, we talked about in chapter 8. Also, because those sediments do not end up jumping the banks and landing in this area, well, then that sediment will just continue to flow down the river, and it will end up at the mouth of the river, and then that causes problems in terms of where the river enters the ocean. Another problem is if you stop the natural flooding that might occur with this river at this point, well, then those waters are going to continue to build as they go downstream, and some town, maybe even in another state further downstream, is going to be affected, and they're going to have increased flooding. So you can see, once again, anytime we try to change Mother Nature, there is an environmental impact further away. And don't just think of rivers here in the United States. You know that there are rivers around the world that flow through multiple countries. So these countries have issues between each other when it comes to how river water is used, for instance. If you're the country downstream, down here somewhere, and you don't like the fact that they're building levees because it floods you too much, you've got an issue. You've got something to deal with. And of course, there's always the possibility of water being diverted from the river. More on that later. All right, so we've got levees. Levees are built to keep water in the river channel. Dikes are a little bit different. Dikes have been built primarily to keep ocean water back. And they're most commonly used in Northern Europe, because northern European countries are pretty much at sea level, and they have to hold back the ocean waters, so they build dikes. For instance, the Netherlands, you're all familiar with them. They've been using dikes for 2,000 years. The problem with dikes is you need some sort of energy source to pump water so that the dikes will hold. And historically, the Netherlands has used windmills for that purpose. But of course, in today's world, they use electric and diesel pumps to do that. Another way that we alter the availability or the movement of water is through the building of dams. And dams are very damaging. You need to know the environmental impacts of dams. Why do we build them? Well, we build them to hold the river water back so that we can control flooding. If we can control the amount of water that ends up down here at the mouth of the river, then we can keep that river from flooding. So when we know that there's problems, we hold the water back. That makes the reservoir bigger, but it also floods areas along the edge of the reservoir. We accept that damage, though, because it's all part of the plan when we build a dam. So you need that word. I just used it. Reservoir is the lake that's built behind a dam. And you know that there's a big height discrepancy here, guys, right? We don't usually build dams unless there's a waterfall that used to be there. This is the largest dam system in the world. It is the Three Gorges Dam. It was built in China for two primary reasons: to control flooding, because lots of towns down here, used to get flooded out all the time, and also for hydroelectric power. We've talked about the fact China needs power plants desperately as their people get out of poverty and they start to expand electricity to all parts of their country. They need to do something besides burn coal for their electricity. So this is a big electricity producer here, the Three Gorges Dam. Alright, so when we build a dam and we have a reservoir, of course, this used to be a skinny little river here, and now it's a big giant flooded reservoir. So we have habitat destruction. There are areas here that used to be, this all used to be land, and now it is water. So that's destroying the habitat for the furry little creatures on the that were once on this land. The other big problem that's an environmental concern when it comes to dams is the ability of migrating fish to be able to get upstream. You're all familiar with the fact that there are many species of fish that need to go back to their home waters to spawn. So in order to have successful reproduction, they need to be able to get past this man-made barrier called a dam. For years, this has been a big problem, going back to the dams that we built back in the 20s and the 30s and the 40s. We started to see a big decline in the number of certain species of fish. So one of the workarounds, literally, workarounds for this problem is something called a fish ladder. And what scientists have done is they've created, again, a man-made water trough that enables fish to get from down here in this area to get around the dam and get up to the reservoir so that they can then continue on to do their spawning. Here's a picture of a fish ladder right here. It's also in your book on page 243. So the fish have the ability to, if they can figure it out, to go up this canal, and it slowly rises. And of course, you know, these fish that go upstream to spawn, they have the ability to get up into the water. Remember, this used to be a waterfall at one point, and they managed to get up the waterfall, so they can certainly manage to get up this fish ladder. So the fish ladder is one example of us trying to work with nature when we build a dam. Here in the United States, we build our dams mostly for hydroelectric power. We do build our dams sometimes for flood control. And unfortunately, every now and then you'll find that a dam will be built for the purpose of creating a reservoir, flooding out a whole bunch of land, and creating more waterfront property. Creating large amounts of waterfront property, of course, increases taxes in the town or the county in which the reservoir is located. The Three Gorges Dam took 13 years to build. It flooded out 13 cities all up this coastline for many, many years, and they had to move more than 1.3 million people in order to build this dam. Of course, when you live in a totalitarian state, you can make that happen. You tell these people they have to move, and they do. 140 towns, 13 cities, 1,350 villages were put underwater to build this largest in the world dam system. There's one other problem associated with dams, and that is the fact that when you stop flooding from happening, or you use a dam to control flooding, well then once again you're interrupting Mother Nature. A certain amount of seasonal flooding is a good thing. Seasonal flooding scours pools and shorelines, and that disturbance favors the colonization of certain plants. Certain animals will come back into the ecosystem once the flooding has happened. Well, if we're controlling the flooding, then those species cannot show up. And that unbalances the ecosystem. Okay, water diversion. Now this is separate from levees and dikes. Levees and dikes and dams are built to hold water back. Water diversion is, just like the name indicates, is used to move water from one location to another. There are some great environmental examples of bad ideas when it comes to water diversion. And the principal way that we use that are called aqueducts. Aqueducts are canals that are man-made that carry water over long distance. We've been using aqueducts since human history, finding ways to move water from one location to another. And this is an example here of the aqueducts that move from the Colorado River, which obviously is in Colorado and has its headwaters in the Rocky Mountains, in order to get drinking water to Los Angeles in California. That's right, 400 400 some kilometers, 250 miles of water is diverted all the way from the Rocky Mountains to the coast of California so that all of those people that live there have enough drinking water. There are lots of examples of not having enough drinking water, even here in the United States. The Miami area, you recall the Everglades story? The Miami area does not have enough drinking water. So they've been sucking water out of the Everglades for a very, very long time now. And they've also decimated their natural water source, the aquifer. Aqueducts, we have lots of different pictures to show of aqueducts all around the world. This is the one here in Colorado. Some other famous examples of water diversion that's gone awry: the Aral Sea, which was previously drained by Russia, and it's near the border of Kazakhstan and Uzbekistan, was once the fourth largest lake in the world, and it has now been drained to practically nothing. You need to know the names of these projects because they've all been on the AP exam before. The James Bay project was a hydroelectric dam project in Canada, but it also turned into a big water diversion project in order to get enough water to flow through their hydroelectric program. The Colorado River I just mentioned. The Colorado River is decimated by water diversion across many, many different states. As a result, the mouth of the Colorado River, which was once a flourishing river that flowed all the way to the end with some very, very strong waters at the mouth, is nothing but a trickle now on the Baja coast of California. Unfortunately, what happens when the river has been diverted by all of these canals, when it gets to the end of its line and it's not flowing strongly, you have oceans pushing salt water in. So you get saltwater intrusion even into that river, and that damages plant life and animal life that can't sustain the increased in salinity because the water's been diverted. So that's the story of the Colorado River. This diagram here is showing you all the different canal systems that are part of the California Water Project. It takes water from these dams here and it diverts water from these rivers, especially the Colorado River, through a series of aqueducts and gets water into LA, San Diego. You get the idea. Even here, even Arizona is involved in the aqueducts that are built to take water out of the Colorado. And as a result, the natural mouth of the Colorado River, which is here, is nothing but a trickle. And this saltwater intrusion happens, changing the flora and the fauna that's living in that area. You might recall the movie Grease. I do. This is the scene from the movie Grease. And there are times of the year, I should say, in California where the aqueducts are not flowing. The way California operates it, they fill them up in the springtime when the snows melt and the river is really flourishing and full. They open up the aqueducts, and this area is virtually full of water for most of the spring and summer. But by the time the fall comes, all the water that was in these aqueducts and being diverted to water treatment facilities and storage containers. So that by the time school starts in September, guess what? The aqueducts are dry, and you might recall this drag racing scene that happened in the movie Grease. Great picture of an aqueduct. Here's another picture. A reminder here about the Everglades story. Remember, the Everglades is really just a slow-moving river that comes from Lake Okeechobee here and ends up flooding an entire region, the area that we now call the Everglades. So this is a actual slow-moving river. What we ended up with was a series of canals and water diversions, mostly to give water to the people that lived here on the coastline, the Miami-Dade area, even West Palm Beach. All of these is so heavily populated, they needed drinking water, and there just wasn't enough in the aquifer. Also, this is a very, very rich farming area. So between the farmers diverting water for their crops and the people diverting water for their drinking needs, and not just drinking, sprinkler systems, washing, drying, or not drying, washing clothes, washing dishes, showers, baths, all those kinds of things. You can see what ended up happening to the big, wide river that was once flowing into the Everglades. As a result, the Everglades are a pretty dried up mess. And I showed you, and we talked about, what the Army Corps of Engineers has done to address that problem. Here's the Aral Sea. What really happened basically is there are two rivers that feed into the Aral Sea, and water was diverted primarily for farming, and as a result of that, the sea got smaller and smaller. But it's not just the smallness of the sea that is an issue, but it's also the fact that with less water, that increases the relative salinity of the water. And indeed, the Aral Sea was an example of so much salinity in the water that fish died. Now, the people that all lived in all of these regions around the Aral Sea depended on fishing heavily for their income. Now they've gone broke because they don't have any fish to catch. And you can see that here it is in 2002, what's left of the Aral Sea. Quite a disaster, really. And of course, this soil isn't even good for anything. Even you would think it might be nutrient rich, but because of the added salinity, the salt that gets left behind in this area, it's no good for farming either. Some experts believe that the Aral Sea will be completely dried up in the next half century or so. Well, I think in the book it says like 10 years. A great example of how humans have interfered in a natural ecosystem. Okay, we saw the statistics back in the last video about availability of drinking water. Well, one way to deal with that is to take the salt out of seawater. If 97% of the world's water is salt water, let's find a way to use that to our advantage and take the salt out. Problem is, no matter which method you use of taking the salt out, it uses a tremendous amount of energy. And that energy has to come from somewhere. If we were to rely on the oceans for all of our water needs, by taking the salt out, we'd run out of coal. We'd run out of all of the non-renewables in years. A few years. But you need to know how these processes work. Distillation is basically building a still. What we do is we have to heat the water to boiling, and when we heat the water to boiling, the water vapor is trapped in these coils. The water vapor comes across, and as it goes across these coils, the boiling hot water, the steam, boiling hot steam I should say, cools. And as it cools, the water drips down into a collecting tank, and of course this is pure H2O now. The salt gets left behind, and that salt is trapped down here in the bottom. This is how we get sea salt. And you notice one of the reasons that sea salt has become a popular cooking device over the last few years is because we have to do something with all the salt that we're claiming from distillation. Yes, there are desalination plants here in Florida, a few, but these plants are very expensive to build, and as I said, it takes a lot of energy to make this water. Water that we used to just be able to pump out of the aquifer, now we have to use a tremendous amount of energy to heat it to boiling. Another technique that's used is called reverse osmosis. With reverse osmosis, well, you might recall the word osmosis from biology. It is the movement of water from higher concentration to lower concentration. That is a natural movement of water and takes no energy to make that happen. However, when you take water from lower concentration and make it go to higher concentration, that requires energy. And that's the idea of reverse osmosis. Basically speaking, you are pushing water through a semi-permeable membrane that's got holes in it so tiny that the salt can be trapped. And that's what happens with reverse osmosis. It takes a tremendous amount of energy to pressurize and pump that water through that membrane to give it enough power to get through a membrane that's got such tiny pores in it that it can trap the salt but lets the water through. Reverse osmosis is the preferred method of turning salt water into drinking water, but it's a very expensive proposition. In fact, it's more expensive to build one of these chambers than it is to build a still. And even though these buildings are huge, they're the size of power plants to be able to deal with enough water each day to make it worthwhile. The fact is that they're expensive to operate. Reverse osmosis is becoming the preferred method though. It's a little bit more economical than operating a still. Ultimately, even if we decide to go this route, it's going to be very expensive, and there's going to be upkeep involved when it comes to building these big buildings with these giant containers of water to build the semi-permeable membranes. You get the idea. Still, in places that are really starving for water, especially in the Middle East, desalination might just be an option. California leads our country in desalination plants, and you can understand why, because drinking water is really at a premium out there. It's a dry state for the most part. Lots of agriculture in that state, so agriculture and industry take a big part of that drinking water. In fact, that's what we're going to talk about in the next video. The availability of water around the world, what it's used for. You might be surprised to know that our usage of water, domestic use, is a tiny fraction of the amount of water that is used all around the world. See you next time.